Hello, welcome back to section 5. We're going to be talking about double angle and half angle identities. Our objectives, we want to use the double and half angle identities for sine, cosine, and tangent functions. So let's talk about what a double angle identity is, okay? First of all, let's talk about the one for sine, okay? So if I've got, say, sine of 2 theta, okay, what I'm doing to this angle is I'm multiplying it by 2, okay? Now for me to get a formula for this, when I multiply something by 2, really what I'm doing here is I'm doing sine of theta plus theta, okay? Now we learned in the last section that if we add two angles together, okay, the sum and difference formulas, we can use that here. And so sine, cosine, cosine, sine. So I'm going to do sine of theta times cosine of theta plus cosine theta times sine theta. Now, we can simplify this, okay? What I can do is I can reorder these, all right, on the right side, all right? And so what I'm going to do is I'm going to do sine of theta times cosine of theta plus, if I reorder that on the right side using the commutative property, I get sine theta times cosine theta, okay? And so now what I've got is I've got two of these things that I'm adding together, sine of theta, cosine theta plus sine theta times cosine theta. So now what I have is I have 2 times sine theta times cosine of theta. And that's all going to equal sine of 2 theta. And this is my identity, okay? And this is where we arrive after we expand this out. All right, so that's my first double angle identity, okay? The next one that we have is we have cosine of 2 theta. Now this one's going to get a little weird. We're going to have a bunch of these, but let's write out, let me do this. I'm going to do cosine of 2 theta, okay? And what I'm going to do here is I'm going to get, this is just going to be cosine of theta plus theta, okay? So cosine, cosine, sine, sine. All right, remember we do opposite of what the signs are for cosine. So cosine of theta times cosine of theta minus sine of theta times sine of theta, okay? Once I have that, I can simplify this, and this is going to give me cosine squared theta minus sine squared theta. And all of this is going to be equal to cosine of 2 theta, okay? Now this is my second identity. Now the cool thing about this is that once I have this identity, okay, cosine of 2 theta is equal to cosine squared theta minus sine squared theta. This is one way to write this, okay? Remember that we can do this. So you don't necessarily need to write this down, but remember cosine squared theta plus sine squared theta is equal to 1. I can write this a number of ways. I can write this as cosine squared theta is equal to 1 minus sine squared theta. I can also write this as sine squared theta is equal to 1 minus cosine squared theta, okay, just by subtracting those. All right, so what I can do is I can rewrite this, and this is going to help us out later on when we do half angle identities. So this is the first way we'd want to write this, okay? However, we could also write it another way. So we could say cosine of 2 theta would be equal to, if I replace cosine squared theta with 1 minus sine squared theta, minus a sine squared theta. Okay, what that's going to then give me, cosine of 2 theta, would then be equal to 1 minus 2 sine squared theta. Okay, so I can write this identity this way as well. Okay, so another way I could write it is, let's replace sine squared theta with 1 minus cosine squared theta. All right, yeah, so if I replace sine squared theta with 1 minus cosine squared theta, so I can get it this way as well, cosine of 2 theta is equal to cosine squared theta minus the quantity 1 minus cosine squared theta. Okay, distribute our negative here, and that's going to give us cosine squared theta minus 1 plus cosine squared theta. And this would give us 2 cosine squared theta minus 1, and that would also be equal to cosine of 2 theta. Okay, so when I have these, cosine has a bunch of them. Okay, I can't really rewrite sine of 2 theta, but I can rewrite cosine of 2 theta using a bunch of these. Okay, it's kind of weird, but that's the idea. All right, the last one that we have is tangent of 2 theta. So if I wanted to find the double angle for that, okay, I would just do tangent of theta plus theta. All right, so tan plus tan over 1 minus tan tan. So tangent theta plus tangent of theta over 1 minus tangent of theta times tangent of theta. Okay, put parentheses around that. Don't have to, but I usually do. All right, tan theta plus tan theta is 2 times tangent of theta over 1 minus tangent squared theta. All right, and so that is my formula for tangent of 2 theta. Okay, so you can always derive these. You don't necessarily have to remember them. However, it does help if we do remember them. Okay, so that's what we've got. All right, so now, let's use these. Okay, and so using double angle identities, let's write these directions down. Let's write down if sine of theta is equal to 2/3, and theta is in quadrant 1, okay, then find the exact value of each function. Okay, find the exact value of each function. Okay, so the first one we want to find is, let's just find the value of, say, sine of 2 theta. Okay, so given we want to find sine of 2 theta. All right, so remember what I'm going to do is I'm going to write down, and let's do this. Before we do anything, I'm going to erase all this real quick. Okay, let's draw this picture out first, and let's figure out the other sides of this triangle. So if this is my right triangle, quadrant 1, here's theta. Sine is 2/3. So my opposite side is 2. My hypotenuse is 3. Let's find our adjacent side, okay, because we're going to need to do that. And that's going to be the square root of 3 squared minus 2 squared. which gives us the square root of 9 minus 4, which ends up giving us the square root of 5. Okay, so this is the square root of 5. All right, so what I know from this, you know, given this picture here, is that, you know, sine of theta is equal to 2/3. I know that cosine of theta is equal to the square root of 5 over 3. And tangent of theta can be written a couple different ways. Opposite over adjacent is going to be 2 over the square root of 5. Okay, now I can write it like that. I can also rationalize our denominator, and we would get tangent of theta is equal to 2 square root of 5 over 5. Okay, if I multiply the top and bottom here by the square root of 5. When we're doing this, because we're going to be operating, we're going to be finding tangent of 2 theta as well. What we're going to do is I'm going to take this, we're going to operate with this and not with this. Okay, we can still operate with this if we want to, but it's a lot easier to rationalize our denominators at the end of the problem when we're doing this. Okay, so the first thing we want to do is let's go ahead and let's find part A, which is just sine of 2 theta. Okay, so let's write out our identity that we've got. And so we can do 2 times sine of theta times cosine of theta. Okay, and since I know it, you know, I've got 2 times sine of theta, which is 2/3, times cosine of theta, which is the square root of 5 over 3. Okay, all I'm going to do here is then just multiply across. And so 2 times 2 gives me 4, times the square root of 5. 3 times 3 gives me 9. I can't simplify this. I don't need to rationalize this, and that is my answer. Okay, so having all those other values allows me to evaluate that. Okay, all right. Let's do the same thing. But let's do it for the next one, part B, which is we're going to find cosine of 2 theta. Now, what we can do, let's think about which one we want to use here. It doesn't matter which one we use. We can use any of these. Okay, we can do cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, doesn't matter. I'll use the original cosine squared theta minus sine squared theta for this. So let's write that in here, that I've got cosine squared theta minus sine squared theta. Okay, and I'm going to rewrite this. I often get confused about cosine squared theta, so let's do cosine of theta, that quantity squared, minus the quantity sine of theta, that quantity squared. Okay, now we know that cosine of theta was square root of 5 over 3. So the quantity, square root of 5 over 3 squared, minus sine of theta, which is 2/3 squared. Okay, and so square root of 5 squared is going to just give us 5 over the 9. Minus 4 over 9. So 5/9 minus 4/9 is just going to simply give us 1/9. All right. And so we can figure those out. Okay. Last one is tangent of 2 theta. And so let's write out our formula for part C. So tangent of 2 theta is going to give us 2 tangent theta over 1 minus tangent squared theta. All right, and remember, tangent of theta, what I'm going to do, in order to evaluate this, I'm going to use the 2 over the square root of 5. Okay, I could use this guy over here, but that's just going to cause too much pain and anguish for us right now. So let's just go ahead and use 2 over the square root of 5. So replace tangent of theta with 2 over the square root of 5. So 2 times 2 over the square root of 5 over 1 minus quantity 2 over the square root of 5, that thing squared. Okay? Now, what I have here, 2 times 2 square root of 5 is just going to be 4 square root of 5, 4 over the square root of 5, over 1 minus. Now, if I square that 2 over the square root of 5, that's just going to give me 4 over 5. Okay, 2 squared is 4, square root of 5 squared is 5. All right, and let's simplify that down here. That's going to give me 4 over the square root of 5 divided by 5 over 5 minus 4 over 5. Okay. And that's going to give me 4 over the square root of 5 divided by 1/5. Okay. So now I can rewrite this as 4 over the square root of 5. Let's multiply by the reciprocal, so 5 over 1. Okay, and so that's going to give us 20 over the square root of 5. Okay, I'm going to multiply the numerator and the denominator by the square root of 5. All right, to rationalize my denominator. So I've got 20 times the square root of 5 over 5. Now the 20 and the 5 divide out, so that's going to give us 4 times the square root of 5. All right, and that is my answer. So yeah, it's a lot of arithmetic once you get down into that, but, you know, thankfully we know how to do that. All right, we got one more on this side. So let's do part D, which is cosine of 4 theta. All right, so part D, we want to do cosine of 4 theta. Okay, now what I can do here is I can do, okay, so on this guy, 4 theta is taking the double of the double. Okay, so what I'm doing here is I'm going to rewrite this as cosine of 2 times 2 theta. Okay, so what I'm doing there, and it's kind of like a U substitution type of thing, but what I'm going to do is now I have this as cosine squared of 2 theta minus sine squared of 2 theta. Okay, and we've already evaluated cosine of 2 theta and sine of 2 theta in this problem. So let me do this. Let me do quantity cosine of 2 theta, that thing squared, minus the quantity sine of 2 theta, that quantity squared. All right. So remember cosine of 2 theta up here. In this example, we got that as 1/9. So I'm going to rewrite this as the quantity 1/9 squared minus sine of 2 theta, which was 4 square root of 5 over 9 squared. So 4 square root of 5 over 9, that whole thing squared. All right, so if I take 1/9 and square it, that's just going to give me 1 over 81. Okay, minus, now when I square this, 4 squared is going to give me 16. So I've got 16 times, square root of 5 squared is just going to give us 5. So 16 times 5, and then all that's going to be over 81 as well. So 16 times 5 is going to give me 80. So I've got 1 over 81 minus 80 over 81. So 1 over 81 minus 80 over 81 is going to give us negative 79 over 81, and that is our answer. Okay, so yeah, it's a little funky, okay, but the reality is that, you know, on this stuff, you know, I'm simply just using these formulas, plugging and chugging, okay? Okay, so on half-angle identities, these are kind of funky, but let's derive them so you can see where they come from. And the way for us to derive them, I want to initially use our double angle identity. So if I use cosine of 2 theta And I'm going to use one of those weird ones where it was 1 minus 2 sine squared theta. Okay. What I want to do here is solve this equation for sine of theta. Okay. So let's do that. What I'm going to do first is I'm going to subtract 1 from both sides. And this is going to give me cosine of 2 theta minus 1 is equal to negative 2 times sine squared theta. Okay, I'm going to divide both sides of this equation by negative 2. All right, and what that's going to do is it's going to kind of move things around. So I'm going to get sine squared theta over on the right side, but then this is then going to become positive. I'm going to do this. I'm going to do positive 1 minus cosine of 2 theta over 2. And so because I'm dividing by a negative 2 here, it's going to make everything in my numerator opposite down here. Okay, and then what I'm going to do is I'm going to take the square root of both sides. Okay, and so when I apply the square root, and I'm going to kind of switch these up a little bit. I'm going to do plus or minus here, square root of 1 minus cosine of 2 theta over 2, and that's going to equal sine of theta. Okay. Now, what I'm doing, the reason why this is called the half angle identity is because if I take this angle here, theta, and if I divide this by 2, I also need to divide this guy by 2. And so what I now have using this is I've got sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine of theta over 2. And this is my half angle identity for sine. Okay. All right, so now let's do the same thing. Let's do it for cosine. All right, so I'm going to use the double angle identity that we had for cosine, and so that was going to be cosine of 2 theta is equal to 2 times cosine squared of theta minus 1. And what I want to do is solve for cosine over on this side of the equation. So I'm going to add 1 to both sides. All right. So I have cosine of 2 theta plus 1, and that's going to equal 2 times cosine squared of theta. Divide each side by 2 and by 2. So I get cosine, and let's do this. Let's reorder our numerator so it matches up with the other side. We had 1 plus cosine of 2 theta over 2 is equal to cosine squared of theta. All right. I'm going to apply the square root to both sides. And so I've got cosine of theta is equal to plus or minus the square root of 1 plus cosine of 2 theta over 2. All right. And then what I can do here, again, is divide this angle in half. And therefore, that angle would be divided in half. And so we would then get cosine of theta over 2, half that angle, is equal to plus or minus the square root of 1 plus cosine of theta over 2. Okay. And then, okay, so that's my half angle for cosine theta. Okay, we've got one more we're going to do, and that's going to be tangent of theta over 2. All right, so if I do that, let's come up over here. Same thing. I'm just going to do tangent of theta over 2, and that's going to equal sine of theta over 2 divided by cosine of theta over 2. Okay. And so sine of theta over 2, we were going to write that as, and we'll just do square root of 1 minus cosine of theta over 2 divided by the square root of 1 plus cosine of theta over 2. Okay. And so at this point, what I'd want to do is since I have a fraction of 2 radicals, okay, I can write this over a single radical. Okay, so this is going to give me the big square root of 1 minus cosine of theta over 2 divided by 1 plus cosine of theta over 2. All right. At this point, I'd want to write this as the square root of 1 minus cosine theta over 2 times the reciprocal. So 2 over 1 plus cosine of theta. The 2's divide out. So we would end up getting, and I'm going to do plus or minus on this because I didn't do that before, but both of these are plus or minus. And I'm just going to have 1 minus cosine of theta divided by 1 plus cosine of theta. And that's going to equal tangent of theta over 2. All right. So when we evaluate, when we're trying to evaluate, and the point of all this, the reason why we're learning all this is so that we can evaluate trig functions that are half angles, okay? And we can use this formula to do so, all right? So let's use the half angle identities, all right? So on this guy, we want to evaluate, okay? And the first one we're going to do, part A, is sine of 7 pi over 12. Okay, so when we're looking at this, you're going, okay, wait a second. I don't have anything on the unit circle that allows me to do this. Okay, but what we can do is we can rewrite this. And if I rewrite this and take half of my angle, let's rewrite this as sine of 7 pi over 6 times a half. Okay, and this one I know. Okay, and what I'm looking for is this denominator, and I go, okay, wait a second. I could rewrite this as something over 2. All right, and use my half angle identity to evaluate this. Okay, so let's do this. Let's rewrite this as sine of 7 pi over 6 all over 2. Okay, and that tells me that I'm going to use my half angle identity on this. All right, so for that, okay, theta in this case, all right, is going to be 7 pi over 6. All right, so to evaluate this guy, what I'd want to do is then do the square root, and let's think about something. Where's theta at? Theta is in quadrant 3, so the y value would be negative. So this is going to be the negative square root. Okay, that's where the plus and minus comes in, depending on where our angle is and the value that we're trying to use here. So since sine is y, quadrant 3, we're going to choose the negative square root. Okay, so now this is going to give me 1 minus cosine of 7 pi over 6 all over 2. Okay, and this is what we evaluate. Now let's figure out what cosine of 7 pi over 6 is. I'm going to draw a quick little unit circle. Pi over 6. The x value is going to be negative square root of 3 over 2. Okay, we've got the small triangle. All right, so that's what I got. So I got minus the square root 1 minus negative square root of 3 over 2 all over 2. So let's clean this up. Negative square root, I've got really 1 plus square root of 3 over 2, all over 2. And so inside of here, I've got negative square root of 2 over 2 common denominator plus the square root of 3 over 2 all over 2. And so then I've got negative square root of, all right, I've got 2 plus the square root of 3 over 2, all of this over 2. So underneath that radical, negative square root of 3, I've got 2 plus the square root of 3 over 2. Multiply this by the reciprocal, which is, instead of dividing by 2, I'm going to multiply by 1/2. And so then this would finally give me that my exact value is the negative square root of 2 plus the square root of 3 all over 4. Okay. And
can we divide by the 2 and the 4?
no, we can't. Good question. The reason why is because we don't have a 2 in front of our square root of 3 that would allow us to do that. Now you could go further with this. You could sit there and you could go, all right, well let's do negative square root of 2 plus the square root of 3 all over the square root of 4. That you can evaluate, and that would give you negative square root of 2 plus 3 over 2. So this would work. This is a square root of 3 inside of there. And so since you have square roots inside of your square roots, you can't, you just got to leave it like that. Okay. Okay, let's do another one. I'm going to do this over here. I know I don't have a ton of room. But let's also evaluate this next one. And I want to evaluate cosine of 67.5 degrees. Okay. And with this one's a little funky. Okay. But what I realize, okay, because the 67.5 isn't on my unit circle. This is half of an angle, okay? And that's just what we have to recognize. So I could rewrite this, what is it, 135 divided by 2? So I would write this as cosine of 135 degrees over 2. So in this case, theta would be 135 degrees, okay? And then we could rewrite this because 135 degrees is in quadrant 2. Okay, it's over here. My cosine is going to be negative. All right, so this is going to be negative root 2 over 2, comma root 2 over 2. All right, because cosine is negative, all right, we're going to use the negative square root. So negative square root of 1, and that's going to be plus cosine of 135 degrees all over 2. Okay, and we can simplify that. Negative square root 1 plus negative square root of 2 over 2 all over 2. Okay, then we're going to get negative square root 2 over 2 minus the square root of 2 over 2 all over 2. So we're going to get negative square root 2 minus the square root of 2 all over 2 divided by 2. And then from there, negative square root of 2 minus the square root of 2 all over 2 times a half. So then this will give us negative square root of 2 minus square root of 2 all over 4. Okay, you can leave it like that. If you wanted to rationalize your denominator, then you'd get negative square root of 2 minus square root of 2 all over 2 would be another way to do it, taking the square root of 4 down here. All right, and that's that. All right, that's all I got for this video. Enjoy. See ya. Bye.